LVDT stand for Linear Variable Differential Transformer. Okay, as you know very well that linear variable differential transformer is used for calculating the displacement. Okay, so it is a electrical transducer which convert displacement into the this electrical displacement. Okay, so this is widely used as a inductive type of a transducer for translating the linear motion into an electrical signal. Okay, so how you can convert this displacement into electrical signals? So this is the operation of your transducer. Transducer is a device which convert one form of the energy into another form. Okay, so that's why this LVDT is considered as a transducer. Okay, generally we have two components for this particular transducer. One is a movable armature, and second one is a transformer winding. Okay, so we have a three type of winding in this transducer. First one is called a center winding, which is a primary winding, and there are two secondary winding right here. Right hand side and left hand side, we place two winding. Those windings are of secondary winding. So we place S1 and S2 as a secondary winding. Uh, this center binding is called as a primary binding, and these right hand side and left hand side bindings, these are called a secondary binding. Okay, you can represent this secondary binding by S1 and S2, and you can represent the primary binding by P. Okay, and in the center of these two binding we have a movable magnetic core. Okay, so this movable magnetic core will move in right hand side or left hand side direction. When you move this particular binding in right hand side or left hand side, displacement will take place. Okay, so we have to record this displacement inside this LVDT. So how you can find out the displacement? So let's see the connection right here. Input supply is applied to the primary binding. Okay, input supply is provided to the primary binding, whereas this S1 will give you one output at this particular point, and this S2 will give you the second output at this particular point. Okay, so these are the differences which produce when your core is moving toward this secondary side or this S1 secondary side. Okay, so when your core is moving toward this secondary side, you will get maximum voltage level at this S1. Okay, when your arm is moving toward this S2 secondary winding, then you will get this S2 voltage as maximum. Okay, so the difference of this voltage will be represented right here, which is a B out. Okay, this working of this LVDT is explained right here. So you know the primary binding is connected to the input supply, that is Vm. So this V is equal to Vm sine of omega t. So this is your input signal. Okay, input supply. 50 hertz is the frequency, and 7 volt RMS is the amplitude of this input signal that is provided to the primary winding. Okay, so this is movable magnetic core. Okay, when this magnetic core move toward this left hand side, okay, so ES2 winding will be showing a maximum positive response. Okay, maximum positive response. So what will happen? Three cases are there right here. First case is when there is no displacement. That means there is no flux is flowing through these secondary winding, that is ES1 and ES2. Okay, so both these voltages across the secondary will be equal to each other. So your output voltage will be zero at this particular moment. Okay, case 2 is there when your rotating arm, or we can say this particular movable magnetic core is moving toward the right hand side. Okay, second case is that this movable magnetic core will move toward the right hand side. Then what happen, this es1 voltage will be the maximum, or it will increase. Okay, this es1 voltage is the maximum, and it will increase. So we will get a positive displacement at this particular moment. Okay, so how you will get the positive displacement? Your output will be given by es1 minus es2. Okay, es1 minus es2. So right here es1 is the maximum. Okay, es is the maximum. So if you subtract es2 from this es1, which result you will get, positive or negative? So positive displacement will be there when you move this coil toward the right hand side. Okay, if third case is there, if you move this movable magnetic core toward the left hand side, so maximum voltage will be there across es2. Okay, so es2 is the maximum at this particular movement. And what is the output if your es2 is maximum? This negative displacement will be there if you move the movable magnetic core toward the left hand side. Okay, this is the center position, zero position. So this is your positive displacement, and this one is your negative displacement. So you will achieve this type of graph in case of LVDT. So this is the output voltage at null position is ideally zero, but harmonic and stray capacitance, or we can say coupling between the primary and secondary, a non-zero voltage exists at a null position. Okay, and second factor is eddy current. When AC current passes through the coil, magnetic field generated across or around the coil, so that will cause this eddy current inside this transformer. Okay, so when a rod is brought to the closer to the primary, to a conductive material, the rod changing magnetic field and generate a current flow in the material. These are called some eddy currents. Okay, so as the eddy current flow through the conducting core, it creates heat. This causes a power loss in the core. So to reduce this eddy current loss, the core is provided with slot. So we have to produce some slots. Okay, this slot cut the magnetic field created, hence reducing the flux, and laminated core is also used for the same purpose. So this LVDT having different type of application. Generally, for we use this LVDT for many industrial purpose and some research application purpose, and to find out some precision type of LVDT to get some sensitive gauging and quality control applications. For submersible LVDT we are using for the industry. We will create the winding right here. So you have to create this circuit like this. Okay, so firstly you select this winding, which is a primary winding, and drop this winding right here. Okay, then you select the armature and drop this armature right here. Then you select the secondary winding and place that secondary winding right here. Okay, after this, what you have to do, you have to configure the LVDT. Okay, so you have to select the number of turns for this LVDT. If you give 1000 number of turns, so primary consists of 1000 number of turns, whereas secondary is divided into two parts. So first winding consists of 500 number of turns, and second winding consists of 500 number of turns. Okay, so it's up to you which value you have to select. You can select it, and this winding will be configured with the 1000 number of turns. Okay, now you have to select the voltage in RMS. Okay, root mean square value of this voltage. So we are going to select a 7 volt RMS value. So it's a amplitude. Okay, then we have to select the frequency. Okay, so you can select frequency with 1000, 3000, 5000. It's up to you which frequency you want to select. Okay, I am selecting right here 1000, okay, hertz frequency, and I am clicking on this configure button. Okay, so when you click on the configure button, you will find the LVDT is showing the displacement right here. Okay, so this is the positive sign. If you move this core toward movable core toward the right hand side, your displacement will be positive. Okay, if you move this core toward the left hand side, your displacement will be negative. So click on the plus side. When you click on the plus side, you will see the waveform is changing in red color right here. So this red waveform you will observe right here, its amplitude is changing. And on the graph side, you will see the value of this particular displacement, okay, is also changing. So at this particular moment, the dot of this red color will be shown right here, and when you scroll your mouse over this red dot, you will see the displacement over it. Okay, so again what I will do, I will click on this plus sign. Okay, you will see the waveform is increasing, its amplitude is increasing, and displacement is also changing right here. Okay, so again if I will click on this plus sign, you will see displacement also changed to 4, and amplitude is also changing. Okay, so in this manner you will see the displacement of the LVDT, this value reach at 7. Okay, and amplitude is also reach at some level. Okay, so this is the positive displacement right here. When you move this core toward the left hand side, what will happen? You will see this red dot is moving backward. Okay, means your displacement is decreasing. Okay, so when you make this particular core at a center level, its its voltage level displacement is 0. Okay, when you move this particular core toward the left hand side, you will see the amplitude again increasing toward the negative direction. So you will see this is the negative direction. When you increase this core toward the right hand side, your amplitude is increasing toward positive side. So one axis is the voltage, that is in millivolt, and second axis is the displacement. Okay, so you will see when I will move this core toward the left hand side, the displacement is also moving toward this negative direction.